So, in continuation of previous class, today I will discuss about the left part of that familiarization of feed mills, layout, designing, and operation of feed mill. So, this is about the proportioning system, how we can proportion the different ingredients under different system like batching system and continuous system. So in case of batching system, individual ingredients will be added in the mixture by using individual hoppers, and in case of continuous system, mixture of different ingredients simultaneously you can add in the mixture, or mixing of or homogeneous mixture of making homogeneous mixture of different ingredients before piloting or before production of the finished product. So one by one I will discuss about the batching system, how it works. So in batching system, the capacity must be fast, which keep with mixture cycle time. It depends on the mixture cycle, size of the mixture, and mixture cycle times is very important in case of the batching system. So capacity must be fast enough to keep up with the mixture cycle time. And multiple scale hoppers, which is connected with the mixture, shorten the batching time. It will reduce the time, whatever time is spent for individual ingredients. So multiple scale hoppers reduce the batching time while mixing the different ingredients. You can see here there are different hoppers which is fitted with the mixture or individual ingredients like ground grains, major ingredients, and minor ingredients, liquid ingredients. That liquid portion pipe is also connected with the mixture, from where liquid, whatever liquid added like oils, molasses, etc., which passes through this pipe, which is meter regulated, and go to the mixer for mixing. And micro ingredient hoppers is also there for addition of the different additives, antibiotics, different toxin binders, etc., supplements through micro ingredient hoppers. So simultaneously different ingredients come to the mixture and mixing to make it homogeneous mixture. Next is continuous system. After batching system, this is the continuous system where ingredient added at the rate of which must be closely monitored to the accuracy. To ensure the accuracy, the ingredient addition rate must be very much important. And individual continuous scale feeders, different hoppers is also there. So individual continuous scale feeder for each ingredient, it should be prepared. So individual ingredients coming through the different individual feeders and mixing under this continuous system. And cycle time, which is very much important for any mixture. So cycle time must be long enough for fully mixing the dry ingredient as well as the added liquid portion of the either oils or molasses. So we can mix. It depends on the mixing or accuracy of that mixture. It depends on the cycle time. How much time should be given for particle cycle, and the cycle time which must allow time for filling and discharging the mixture. Size of mixer, which is very much important, which requires mixing time, and ribbon size as well as the number of the ribbons which is present in the mixture, by which by that ribbon they mix the different ingredients. So a standard ribbon mixture which requires 3 to 5 minutes for mixing. This is the standard time, 3 to 5 minutes for mixing under a standard ribbon mixer. And twin rotor, sometimes twin rotor also available in the mixer. So twin rotor and a special agitator mixer which fully mix the ingredients in 1 to 1.5 minutes. So in case of twin rotors, we can reduce the time of the mixing by 50% almost. Here you can see that the batching the scale and mixer. In this photograph, this is the scale hoppers where the ingredients coming to the mixer. Liquid portion pipe is monitored, that means metered reading is controlled, the liquid portion will be controlled by the meter. So here you can see that the liquid manifolds. Mixture, this is the mixture portion of that plant, and vent part where they act as the reservoir. So this is the vent part, and serving where dust particle and other things were collected, and after the mixing of the ingredients, they coming to the feed ingredients, mixed feed ingredients coming to that portion. Twin rotor mixer, here you can see that this is the mixer having twin rotor type intervent search beams. So after mixing, the ingredients coming to this portion for further processing. So this is the twin rotor mixer photographs. Piloting system, here you can see that how pilot is being made in the feed mills plant. So this is the pilot unit, and size of the pilot depends on the size, capacity of the plant, how much ton per hour need to produce by that particular plant. So capacity which depends on the horsepower of that pilot unit and motor, and capacity which varies with the ingredients. What kind of ingredient we should we have to use for making the feed, how much liquid it should be added in that particular feed, and the size of the pellet. So capacity varies with the size of the pellet, liquid added, and types of the ingredients. And a minimum 2 mass beam which should be located near the mills. So this is about the piloting system, how it works and how it looks like in feed unit. There is one horizontal which is 18 to 21 cubic meter per minute of air, which is being passed per metric ton of capacity of the feed plant, and which requires, this cooler requires high maintenance, because this is very important part of the pilot unit. Cooling is very important part of the pilot unit, and air should be passed properly through that cooler. And counter flow cooler, this is the horizontal cooler, and this is the counter flow, which where 12 to 16 cubic meter per minute of air per metric ton of the capacity should be required, and that counter cooler having low maintenance cost in comparison with the horizontal cooler. After cooling of the pellet, we should go for the bagging system. How we can bag it properly after after production of the pilot and finished product. So bagging system is also very much important, and manual bags which kept it and seal it. So there are different sealing machine. From here we can pack it properly, and which requires 1 to 2 manpower to operate it, and manual system around 6 to 8 bags per minute we can seal it and we can pack it. So bagging system is also very much important, and trained persons should be required for bagging and sealing that bag. And in case of automatic bag, the filling, placement and sealing which can be made automatically, and this requires a stocking of new bags in bag hangers. We should keep that bags in particular area, and the machine automatically do this work like placement and sealing of the bag. And in case of automatic system of the packaging, 18 to 20 bags per minute can be filled and seal it. So there is a lot of time, we can reduce the time consumption as well as the manpower in case of automatic system of packaging. A minimum 2 supply bins which should be placed above the packaging system. So by that way we can also reduce the time of the packaging. So 2 supply bins should be there at least, and supply bin capacity is based on the batch and lot size. That means it's based on the per hours how much tons capacity of the finished product is being produced by that particular feed mills. So it depends on the capacity of the feed mill, how much that packaging bins should be allotted. After packaging, that warehouse must be there in the feed mills, where packaged material and finished product before transportation to the market. So allow adequate space for storage of individual baggage, batch wise, and which kind of the feed, different composition feed for different species feed millers prepare. So arrange those finished product in such a manner batch wise to avoid the mixing of the different feed baggage, and the product should be arranged so oldest product used first. In that the arrangement should be made in such a way that the oldest product should be used first, or should be sent to the market first, and the product which should be located in warehouse, which is to be minimized to travel the distance to and from a storage area. So we should keep in mind to distance to minimize that time to cover the distance. In that way, we should keep our finished product accordingly. Here you can see that bulk feed load out, how we can load and unload the bulk feed. So there are different ways we can sell our product, and weighing scale must be there uh, while we transporting the material. So truck scale, weigh lorry, batch weight. So this kind of a system must be there in the feed mill for proper weighing of the finished product as well as the raw as well. And there are a number of bulk product bin. They can also keep the product or finished product in the bins as well. And based on the amount of the feed which is being produced by the feed millers and the number of product in the bin size depends on, and the number of the bins also depends on the number of the products. So different feed millers produce different products. So accordingly, they can increase or decrease the number of the bins of the finished product. Truck capacity, how much truck, 10 ton, 20 ton, 25 tons. Like that it also depends on the truck capacity. The bin size also depends on truck capacity, loading time, available loading time, and schedule of the movement of the truck. So these are also very much important for feed millers, and capacity of the bulk product bin, which is based on the size, batch size, and the requirement of that particular product. So lastly, in this familiarization of the feed mills layout and designing, I would like to sum up the presentation of this particular topic, that the product mix for the facility, which must be clearly identified and understood. We should understood first how the product mixing facility is available in the feed mills and the production requirement for each type of the product, which must be determined to identify the equipments, what kind of equipments needed for particular type of the product. And plant capacity, both current and future, which must be determined to make sure that the key system will handle all the capacity level. So this is very much important, the plant capacity, and how we can expand our plant capacity, that feed millers in future. And the process flow of the mill, which must be defined and draw before any physical layout of the mill. So process of the flow of the mill, which must be defined and draw before any physical layout of the mill is started. So this is also very much important point, and we should keep in mind the before establishment of the feed mill. And provision for future equipment and system, which must be included in the initial mill design. Actually, for future expansion, we should keep in mind that what we can do in future and how we can expand. So lands and other financial matter which should be kept in mind for future expansion of that particular feed plant. So these are some basic facts about the feed millers, these feed mills, their layout, and how it work different component in feed mills. So this is about the today class. So thank you very much.